All right, class, today we are actually going to compare a couple things we've looked at in gravitational forces versus electric forces. I know we've talked about how gravitational force is a very weak force in comparison to strong nuclear, weak nuclear, and electromagnetic forces, but we actually want to do some math to prove it. So if we look at our problem, it says almost all stable matter in the world is composed of protons, neutrons, electrons. Properties are listed in the table to the right, given a mass and charge of all three. To compare the electric and gravitational forces, imagine an electron and a proton are separated by a unit of 1 meter. Wants to first find magnitude of the gravitational force between the two, or gravitational attraction, the magnitude of the electric attraction between the two, electric force, and then which one's stronger and how many times stronger is it. So first, we get our picture so we know what's going on. We are going to go ahead and do the gravitational force first. So if we look at the force of gravity, we know that it's g times the mass of the first object, mass of the second object, divided by the distance between the two. So we know all of these. So first, big G is 6.67 times 10 to the negative 11th newtons meters squared over kilograms squared. Okay, so big, really small number, but we know what it is. And then we have to do the mass of the first object and the second object. So we have the mass of the proton is 1.6726 times 10 to the negative 23rd kilograms. Multiply that by the mass of an electron, which is 9.1094 times 10 to the negative 31st. So really small. And we divide that by the distance between them. And again, we said that was 1 meter. Square it. And that gives us a gravitational force of, plug that into a calculator, 1.02 times 10 to the negative 67th newtons. Now, that is a very small number, but that gives us our gravitational force. We have to do a similar thing, just plug in some numbers to find the electric force. And we know that the electric force, which I'll call F of EL, is just K times charge of 1, charge of the second, again, divided by the distance between them squared. And that gives us, if we plug in our numbers, well, K is 8.99 times 10 to the 9th. 99 times 10 to the 9th Newton meter squared Coulomb squared. And then we do the charges. Well, charge is 1.6022. 1.6022 times 10 to the negative 19 coulombs. Well, we can multiply that by the same thing. Again, except it's going to be a negative 1.6022 times 10 to the negative 19th. And again, distance between them has not changed. It is still 1 meter. Still square that. So coulombs squared, meter squared, they cancel out, we're left with newtons. The electric force is therefore 2.31 times 10 to the negative 28th newtons. Now again, that is a pretty small number as well, but if we compare them, obviously the gravitational force is much, much smaller, negative 67th power versus negative 28th power. And if we actually want to get how many times stronger it is, we just have to divide the two. So I'm going to take electric force divided by gravitational force. So I bring that up here. So electrical force over gravitational force. And we do 2.31 times 10 to the negative 28 newtons, which was our electrostatic force, divided by 1.02 times 10 to the negative 67. We're going to see that the electric force is 2 times 10 to the 39th time stronger than our gravitational force. So it is much, much smaller, or much, much greater than the gravitational force, even though they're both pretty small.